Right, welcome to another edition of Data Structure and Algorithm. Okay, so I'm your host Morgan Epika Izukawa Jr. So we're going to look at the overview of data structure as well as the algorithm analysis. Okay, so on our objective for today, we should be familiar with problem solving. Problem solving is one of the most critical things that we hold to have and achieve. Okay, then we should also be able to develop and implement algorithms. So at the end of this session, we should be able to develop as well as implement algorithm, and you should also be able to trace algorithms using the programming as well as the coding languages. Okay, we should also be able to select appropriate data structure and algorithms for a given problems. Okay, then now let's look at the quick background of what data structure and algorithms are about. Okay, so some of the prerequisites, these are various as well as the variables and the expressions. So in here we talk about the methods, functions, as well as the procedures that are used in a computer language. Decision structures can either be like if a statement or a switch statements. Illustration structures for like loops or while loops. Then we also have classes and objectives like objects. So these are some of the things that are used in computer programming, like to make because a computer, you must understand that a computer, it also it usually responds to a certain language, which is just the programming language. Yeah. Then, what is data? That's just a very good question. Someone can ask to say, what is data? Okay. So, yeah, data is just a collection of facts from which conclusion may be drawn. Okay, so when you talk about facts, you're talking about actual things, like things that are real time things. Yes, an example can either be example of data. First, say for example, today we do your, like we take your temperature. Maybe it is 37.5 degrees Celsius, or maybe just at 36.4 degrees Celsius. Then that's just the fact. It simply means that at that particular time, your temperature is at that degree Celsius. So we can draw a conclusion from there that this is how your body is. If it is above 37.5 going up, we can say that is hypothermia, or maybe it is yeah, fever due to hypothermia. Or if it is less, we can say that is low, like if it is less than maybe it's less than 35.5, it's below that one, it's hypothermia, like low body temperature and whatnot. So all that talks about the factual thing that usually happen. So now then we have what we call the types of data. So under types of data, we have four things that we should need to take into consideration. The first one is the textual data. Textual data, this one, for example, your name. What's your name? Maybe your name is Benson. Then that's your just textual data. When you tell me maybe we're meeting for the first time, and then I ask you to say what is your, my friend, I ask you to say what is your name, then you tell me that your name is Morgan, or maybe your name is Victor, or your name is Sharon, or maybe your name is um, um, Rebecca and whatnot. Yeah, then that is just the textual data. Then, if we talk about numerical data, we are just referring to like your ID, like what is your, because numerical, we are referring to numbers. Remember, numerical numbers, referring to your national identity card. For example, if you're a student, I can say, what is your roll number? Or maybe I can ask you for your ID number or your computer number and whatnot. Okay. Then for audio data, we're referring to examples such as your voice. Like for example, you can be able to recognize someone's voice even without seeing that person. For the fact that you know that person, for the fact that you know that person, you'll be able to get and recognize their voice. I'll give an example. If you know your girlfriend very well, you know your boyfriend very well, even if you've not seen them, but for the fact that you've heard their voices or you've heard his or her voice, you'll be able to tell, to say, ah, that's my man or that's my girl. Yeah. Then there is also what we call the video data. Under video data, for example, these are just your voice or picture. Maybe you create content. Remember content creation where you come up with something, then you put up a video and you do whatnot and so on. So those things are just what we call video data in programming. Okay. Then we have what we call data types as well as data structures. So in data types and data structure, what is it that is involved? Number one, we talk about applications. On application or programs, we have applications as well as the program that are they read data as well as the store data temporary, or it processes it, and finally output the results. It is data. So data, or it is data, can either be numbers, characters, etc., etc. Like in an illustration, in an illustration that we have here, we have data that is pointing into application or programs, which is also giving out another data. So what we are trying to entail in here, we are trying to come up with something which is, we have the input data. This is the information that you feed into the computer. And then the output, the information that you get after feeding, after the processing, that is what we call the output data. Right, okay. Then data is classified into data types. It can be like the char, the float, the int, etc., etc. So those are just the classification of data. So data types, we have the first one is domain. Domain allowed. This one, domain is just the allowed value. Then the second one is just an operation, a set of an operation of other variables or values. Then we have what we call a compiler signal an error if wrong, like if wrong operation is performed on a data of a certain types. Like for example, a char usually uses xyz or xyz. Then we have z equals x star y, which is just not allowed. Okay, so we use these things in pseudo-codes as well as computer programming, C++ as well as Java and whatnot. Okay, so then let's look at some of the examples that are involved in data structure. So data structure is just the process of making something using the data types to come up with something, that a structure that is well conclusive and it is reasonable to understand and to code a particular program that we want a computer to code. Like we have data types, domain, and operation. Like the button here, it has the domain is 0,1. Operation, we have and, o, equals, etc., etc. Then the char, we use ASCII. Then the operation we use equal to, less than, greater than, less than, etc., etc. Then on the integer, we have the maximum, into, as well as minus, and then we have plus, which is the maximum, the minimum, as well as the maximum into. So the operation you use the positive, plus, minus, which is negative, equals, less than, greater than, etc., etc. Okay, so then we have what we call simple data. Okay, under simple data, what is it that we have? So in simple data, what we have is it is also known as atomic data types, where we have no components parts. For example, the int, the char, the float, etc., etc. Like we can either have 21 as in the int, and then we can either have 3.14, that is just the char, and then we can have the float, which is just a, etc., etc. That is just the simple data. Now, what is data structure? Now, when we talk about data structure, we're talking about a particular way of storing as well as organizing data in a computer so that it can be used efficiently and effectively. Okay, so data structure is the logical and mathematical model of a particular organization of data, or just a collection of data. Yeah, can put it in that format. Okay, so a group of data elements grouped together under one name. Like for example, we've got the arrays of integers. Okay, like we have another one which is just the structured data. So structured data, these are just types that can be broken into components parts. For example, object, arrows, sets, files, etc., etc. For example, we also have a student object where we have the student name, the age of a student, the branch, as well as the component and whatnot. So all those things, you got the row, the column, where you put up something like that. Like we can take for instance where we say here is the list of all the students that we have at this particular university. So you'll be able to take the student number, the student name, the program that they are doing, the computer number or their roll number and whatnot, all those things, and then yeah, the courses that are trying that are given to them and whatnot. So all that details is what is put in what we call the data structure. Now in a computer, you use what we call the computer language, the language in which the computer will understand and will be able to express and interpret your information to program a software. Okay, now types of data structure we have, there are many, but we name a few. So we will learn these data structure in a great detail. Okay, so we got the arrow, which is that one there. Then beside that, we have another one, which is the linked list. Okay, then we have the tree, which looks like that, arranged in a tree manner and whatnot. Okay, then we have the queue. This one is just arranged in a queue form. Then we have the last one, which is the stack. This one is a stack, as in the stack. Yes. Okay, now the need for a data structure. Why do we tend to have a need for a data structure? Okay, let's look at that. Let's go and follow me through. Okay, number one, the goal is to organize your data. So what it means is that you need to organize your information. Your information should be well organized. In as much as you are presenting this information to maybe your faculty, or maybe it's an assignment, or maybe it's a research that you're doing, or maybe it's you're coding a certain software, programming a certain software and whatnot. You need to have a goal. Your goal is that your program that you're doing, at the end of it all, it needs to be organized. Your information should be organized. It should not be scattered, like scattered. The information is anywhere, all over the places. No, that one is not necessary. Okay, so your info has to be simple and well organized. Then what are some of the criteria? So criteria, we need to facilitate efficient. So in here we mean about the storage of data. So you need to have a good facility where you can store your data. Then you also need to have a retrieval data, a backup. Like other people usually move with hard drives, and others they usually back up their information on the Google Drive. If you're using an Android phone, you can use the Google Drive Express. If you're using an iPhone like me, you can use the iCloud account. Remember, if you're signing up for the first time, they usually give free 15 GB, the gigabytes that you usually give, and then you can also buy and purchase as much space as possible. You can even purchase a 1 terabyte, or even 100 GB gigabytes. Okay, now design. So design issue, we need to select and design appropriate data types. This is just the main motivation to learn and understand data structure. Okay, so data structure operation. So under data structure operation here, we just demonstrate using the classroom example. So when we are demonstrating using the classroom example, this is where number one, we really need to know the navigating principle. The navigating principle, this one, it gives us the access. It gives us the access to each data element exactly like once so that the certain item in the data may be processed. Like navigating is just like finding, looking at maybe what thing should we put there, and so on and so forth. Then the second one is searching. So searching, this is very much important as you are doing your data structure operation. Searching is very important. Under searching, this is where we find the location of the data element in the key or in the structure, or even as you are coding a software or a program. Then we also have what we call insertion. So under insertion here, it is where we add a new data element to the structure so that it looks suitable and well organized. Then we have deletion. This is where you remove certain things that are not making sense, things that are not even adding any value or any complement to the structure that you are putting up. So this is why we remove the data elements for a structure. Then we also have the sorting. Sorting is just the way we arrange the data elements in a logical order, or it can either be ascending order or descending order. Remember when we talk about the pseudocodes, the flowcharts, all those things, they can either be arranged in an ascending order or a descending order. Yeah. Then we also have what we call merging. So merging is where you get these elements and this component. You get component A and component B, and then you add them using the programming language as well as the natural language. You program the two. When you get the natural language program as well as the programming language, then you put them to when you put them together, what that simply means, it simply means that you are merging, you are combining these data elements to form two or more data structure. Yes. Now, what do we mean when we say what is algorithm? So algorithms, this is just the infinite set of instructions which accomplish a particular task. Yes. Or a method or a process to solve a problem. So we use algorithms to solve problems. Okay, what does that mean? Like usually involves like transforms the input of a problem to the output, or where we have this formula where we say algorithm equals input plus process plus output. So in here I'll give an example of the way the calculator has been fashioned, scientific calculator per se. Okay, so if you say you press in something, you press a problem in a calculator, like you press 2 plus 4 times 5, 2 plus 4 times 5, your computer is your calculator is well coded using the mathematical notation of which it will even follow the bid mass. It was way back, it used to be board mass, but now it's bid mass. There is indices due to the calculus that they've brought at the what is the secondary level. Okay, so now when you look at all that thing, when you put 2 plus 4 times 5, then your calculator will give you, that is the input. You're putting in a problem which is 2 plus 4 times 5, then the output, which is the answer, it would be 22. Yes. Algorithm development is an art. So once you become a problem solver, this one, it's an art. What do you need? It needs practice, 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 and only practice. If you want to be a problem solver, then you need to practice a lot of algorithms, because algorithms, these will give you certain things that you can, they'll make you to start thinking in a critical way while you are going to use certain software, certain programs to come up with a solution that will be able that will eradicate certain problems that we are facing in our day-by-day life situation. Okay, what is a goal of a good algorithm? So what is a good algorithm. So a good algorithm here, it must be correct. Very, very, very necessary. So for your algorithm to be good, it must be correct and accurate. It must be finite, which is just the term of time as well as the size. Okay, then it must be terminant, and it must be uh, unambiguous. Okay, then which step is next? Okay, then the last step that is just next, it must be space and time efficient, meaning that it should be able to last for a longer period of time. Yes, so a program is just an instance of an algorithm written in some specific programming language. Okay, now I'm going to introduce you to what we call the PL and the NL. PL means programming language, NL means the natural language. Okay, so a simple algorithm. Problem: find the maximum of A, B, C. Okay, algorithm, it is going to be like this because we are putting this info in a computer. So we need to put this information in a way, in a language that a computer will be able to understand. So we'll put up our pseudocodes. So our pseudocodes would be input equals ABC. Output would be output equals maximum. Then progress. Let the maximum equals A. If B is greater than maximum, then maximum is equal to B. But if C is greater than the maximum, then maximum is equals to C. Then display maximum. So if you're going to display the maximum, you're going to put up something that would be A equals B equals C. Okay, that will be your display of the maximum. These are just pseudocodes. You can put them, yeah, the flowchart and whatnot. So order is very important. The order of your format in which you are programming your software, it's very much important. Okay, now algorithm development basics. So what are some of the basics that you need for you to develop these algorithms, the pseudocodes? Yeah. So number one, you need to clearly identify what your output is required, without which it won't be, you can't come up with these programming software. And then what is the input? You need to know what is the input, because your input will determine the output required. What steps are required to transform the input into output? So you need to know everything. Then the most crucial bits, okay? The needs problem solving skills, you need to have them. A problem can be solved in many different ways, which is very true. Which solution amongst the different possible solutions is optimal? That's a question. That's $1 billion question that you need to ask yourself with what you're doing and you want to code this particular program. Which solution amongst all these different possible solutions is optimal? Like, you can get advice from people that will tell you this and that, but at the end of it all, it's up to you to choose which one are you going for, and that is your optimal possible solution. Okay, now let's look at how to express an algorithm. So we have a sequence of steps to solve a problem. We need a way to express this sequence of a step. Like, it can either be a natural language, which is NL, which is just an obvious choice, but not a good choice. Why? Because natural language are notoriously ambiguous, like they are unclear, like it really leaves you blank. Like, imagine, have you ever heard of a story where you find to say that this is an interesting story, or maybe you are watching a movie and this movie was just okay, and then it has attracted your attention, then suddenly just cut to say it has just ended, then it's unclear, it has just left you with something that is with question mark. So that's what natural language is. When we say natural language is an obvious choice, but not a good choice because it is notorious sometimes, like notoriously sometimes, and ambiguous and it's unclear. Then programming language is also another choice, but again, not a good choice. Why? Because algorithm should be a programming language independent. Yes, these ones you need to program them independently, and we need some balance. So in the balance here, this is where I talked about the margin. Remember the margin? What did I say about the margin? Under margin, I talked about where you get two components. You get the natural language as well as the programming language. You merge them to make one. Okay, so that's what it means when we say we need some balance, and we need the programming language independence, and we need clarity. We need pseudocodes which provides the right balance. Okay, what are pseudocodes? Wow, that's $1 billion question. Pseudocode is just a short annotation for describing a computer program. Remember, computer programs are written in form of pseudocodes. Rather than using a specific syntax of a computer language or more general wording that is used. Okay, it is just a mix of the natural language and the programming language expression in a systematic way. Using pseudocodes, it is clear for a non-programmer to understand the general working of the program. Yes. All right, okay. Now, pseudocode general guidelines. So using of the programming languages construct that they are consistent with modern. They move with technology. These ones, computer, it usually moves with like technology. It usually move with technology, and that's the reason why certain software that were used in 1960s, 1970s, 1980s, 1990s, 2000 and 2021, we're in the 2023 now. You're going to agree with me that technology is advancing. Certain software outdated. Remember Windows? We used to have Windows XP, Windows 7, Windows 8, Windows 10, Windows 11. It's also there, and they are just keeping on updating. Now imagine in the latter future, like let's say 2050. Have you seen that even this computer program will kindly, like, it is going to evolve? Yes, it is. It will evolve consistently because it moves with the modern technology, and it has a high levels of language. For example, C++, as well as Java. These are the other computer programming softwares and copies that you can use when you are programming a software or coding a robot. Okay, then use appropriate comments for clarity and be simpler and precise. Okay, now let's look at these expression components of pseudocodes. Expression, these are just standardized mathematical symbols that are used, like the left arrow sign. In computer language, you can put ij as the assignment operator in the assignment statements, equivalent to or equal to operator in Java. Then the equal sign, which is the equals, is the quality relation of the Boolean expression, which is equivalent to the equals relation in Java. Or for example, we can use the sum ij, okay, which is just a left arrow sign, then we put 0, or the sum ij, sum plus 5. What is the final value of the sum? So in here, these are just some of the codes that we use in computer programming. Yeah. Then components of pseudocodes, here continuation. Okay, so this is where we are now going to talk about decision structures, like if then else logic. Okay, like for example, the if condition. And remember, in the flowchart, we use the diamond. Why do we use the diamond? Because the diamond is referred to as the decision box. So if the condition then is true, action, Else, the false action, we use the indentation to the indication that the condition should be included in the true action and the false action. For example, if the marks, if the marks is greater than 50, then print congratulations. Print congratulations if the marks are greater than 50%, meaning that you've passed, like you've passed. Okay. Else, but if not, if the marks are less than 50, then else print sorry you failed, then end if what would be the output mark are just less than 50. Yeah. Okay, now the question says, what would be the output mark? What would be the output if the mark are equal to 75? So the output mark would be excellent, like congratulations, you've made it. Okay. All right. Okay. Then continuation. Then the loop repetition. We have the precondition loops, which is while loop, while condition, do action. We use indentation to indicate what action should be included in the loop action. Like for example, while the counter, like it's less than 5, do print well done to CS 204. Yeah. Then the counter ij, counter plus 1, wow, end wow. What would be the output if the counter is initialized to 0.7? Okay, so these are just some of the computer coding programs. Loop repetition, like these are precondition loops, like for loops, for variables, increment, definition, to do action. For example, for the counter ij 0, counter less than 5, counter ij, counter plus 2, do, then print welcome to CS 204, then end. What would be the output? All right. Okay, so again, the repetition, this is where now we put, these are just pseudocodes, programming computer languages that we use. Okay, then the other method, declaration, these are just the return types methods, like the name parameters list, the method of the body. For example, the integer sum 1, integer number 2, or start, where the number 2 results ij, number 1 plus number 2, end. Method calls the object method, which are the args. For example, we have my calculator, sum, open bracket, sum 1 comma sum 2 close brackets. Okay, so these are methods that are used in computer, the arrows, the comments, and all these things, the brackets. These are most of the components that we use in algorithm. Okay, algorithm design practice. Example 1, determining the even and odd number. A number divided by 2 is considered to be an even number. Yeah? While the number which is not divisible by 2 is considered to be an odd number. Definitely. Write pseudocodes to display the first number is an odd or even number. So in here, remember, you put the pseudocode in the computer language. Example 2, computing weekly wages. A gross pay depends on the pay rates and the number of hours worked per week. However, if you work more than 40 hours, you get paid time and half of all hours worked over 40. Okay, write the pseudocodes to compute the gross pay given rate and hours worked. Okay, so these are just some of the examples that we'll look. Thank you for this edition, and ensure to subscribe to my YouTube channel for more contents of these, and comment in the comment section below, and also follow my link down in the description below. Shalom, this has been your host Morgan Epika Izo, Docs Kama Jr. Yeah.